discussed about privacy preserving reselection for protected biometric identification using public key encryption with keyword search. Now we are going to discuss about overview of our project. The efficiency of biometric systems, in particular efficient and accurate biometric identification, is one of the most challenging problems in biometrics today. As a solution, this work proposes an efficient privacy preserving reduction of the computational workload of biometric identification systems using public key encryption with keyword search. Here the system is identify the person is authorized and unauthorized, so we can extract the biometric informations for particular persons. So the system will be encrypted. If the person is authorized, the user can view or the user can decrypt the original information, and or else the user can't able to decrypt the original informations. The system is developed the machine learning algorithm for classifying the person is authorized and unauthorized by using random forest classifier. Finally, the experimental result shows that some performance metrics such as accuracy and error rate. This is the overview of our project. Then we are going to see about flow of our project. This is the flow diagram. Here we have collected the set of images, that is the data set ferret face images. So we can select one input image from our data set, then pre-process the original image. In this step we can resize the original image as well as grayscale conversion. Then the pre-processed image or carry out to feature extraction module. Here we can implement local binary pattern, so we can extract the features by using this algorithm. Then biometric information. Here we can extract the biometric information such as the name, person name, then person age, sex, whatever it is, from corresponding input image. Then encryption. Here we can encrypt the extracted biometric information by using RSA. Then classification. Here we are going to implement random forest algorithm. So with the help of this algorithm we can analyze some performance metrics such as accuracy and error rate. Then with the help of this algorithm we can classify the person is authenticated or unauthenticated. If the person is authentication means they can decrypt the encrypted data, or else the user can't able to see the original informations. So the decrypted and encrypted data will be stored in cloud. So here we are use some cloud storage free software, that is the CloudMe. So this is the flow of our project. Now we are going to discuss about demo of our project. So this is the ID which we are used for running our project. So spider ID from Anaconda Navigator. So here, so this is the data set. So here we can choose any input image from our data set. So it can predict either if the person is authenticator or not authenticator. So we can choose. So I choose the first image. Okay, so this is the input image which we are selected from our data set. Then this is the resize. Here we can resize the original image. Then we can convert the grayscale. The next one, feature extraction. So this is the output for extracting the features by using LBB. Here we can extract the biometric informations. So the corresponding input image, the person's informations will be displayed here. The person name, age, then either it's female or male. Then encryption. Here we can encrypt the our extracted biometric information. Then performance analysis. So this is the accuracy for this is the error rate. By using random forest we can estimate these performance comparison. Just it is a graph, performance graph. Identification. Here the person is authorized. If the person is authorized means the decrypted strings will be displayed. Again I can run our project. So I can choose one image. So these person also authorized. The person is unauthorized, so the person is unauthorized, so they can't able to decrypt the file. The data will be stored in CloudMe. So encrypt, then decrypt. The encrypted informations will be stored here. Decrypted information, so the data will be stored in CloudMe. So this is the output of our project. Thank you.